Hello everyone, this is Harrison. So today I'm going to show you how to solve the problem Kirchhoff's current rule ranking. So in this problem we will have three circuits, and for each circuit we will be asked to compare the current through the various resistors, and in each of the circuits all resistors are identical, which means their resistances are the same. Okay, so this is part A. We will have three parts. Okay, let's begin. Part A. Rank below the three identical resistors A, B, and C in figure 1 on the basis of the current that flows through them. Rank from largest to smallest. To rank items as equivalent, overlap them. Okay, so this is figure 1. And in order to make it look easier, I draw it on paper, and I also use color pencil to highlight wires that have the same potential, like this one and this one. Okay, so in order to solve this problem, we will need to use the junction law, which is this one. The total current flowing in the junction is equal to the total current flowing out of the junction. What does that mean? That means in this case, IA will equal to IB plus IC, and because all three of them are positive, so we will have IA is larger than the other two. Okay, I will write here. So now we need to compare IB and IC, and to do so we will need to use the Ohm law, which is this one. I equal delta V divided by R. So I write it here. IB equal to delta VB divided by RB, which is R. Yeah. And IC equal delta VC divided by RC. And RC is equal to RB because they are identical. Okay, so like this. So now, as you can see in this picture, these wires have the same potential, and these wires also have the same potential. That means resistor B and resistor C have the same potential difference, which means delta VB equal to delta VC, and then their resistance are the same. That means IB equal to IC. So the final result is IA larger than IB equal to IC. Okay, and here I put IA to the left, which is the largest, and then IB and IC to the right, and they overlap, and that answer is correct. Okay, now we will move to part B. It actually asks the same question, however now we have a new circuit, and it is this one. Yes, this is the new circuit, and in order to do so I also draw it to the paper and use color pencil to highlight the wires that have the same potential, like this. So first we can see that the resistor A and resistor B are connected in series. That means IA will equal to IB, and I know that by using this law here, this one, the conservation of charge. The current is the same at any 2 points in a wire, and also these two values are also equal to their combination current, I mean their current equivalent, which is IAB. We can use that rule by using this key. It says the current and the power output of the battery will be unchanged if the N series resistors are replaced by the single resistor are equivalent. So now we already have IA and IB, and we need to compare with IC. So here I will treat these two resistors as an equivalent resistor, which is AB. Yeah, let's call that. And I also use the Ohm law like the previous problem. So I have IAB equal to delta VAB divided by RAB. And in this case, because these two are connected in series, so I can use this law. It's called resistor series or series resistors, like this. And this law said the resistors equivalent or equivalent resistance is equal to the total resistance of all resistors in that series, and that means delta IAB will equal delta VAB over RA plus RB, and RA is equal to RB, so we can say like this: delta VAB over 2R, and which is like half of delta VAB over R. And now for resistor C, we also use the Ohm's law, which is like this. So now let's compare these two. In this diagram, we can see that the resistor C and the equivalent resistor AB have the same potential difference, which is these two, and they have the same resistor R here, but here it have half times this one, and this is like it just stay the same. So here we can write like 1/2 times delta VC over R, and that means IC is larger than IAB, and because like this, and because IAB is equal to IA and IB, so our final result is that IC is larger than IA and IA is equal to IB. So that means we will put the C to the left and AB overlap like this. Yeah, so we put like this: C to the left, which is the largest, and AB to the right, and they overlap because they are equal to each other. And the answer is also correct. Now we will move to part C, which is also the final one. So in this problem, we will need to compare the current flow through 4 resistors instead of 3, like the previous 2 problems. Okay, so this is the diagram. Okay, this one. And in order to make it look like easier to solve, I write down to paper. I draw it down to paper like the other two. And in this problem, if you watch closer, you can see that this part is actually the same as the part A, and that means we can say that IA larger than IB and IB is equal to IC. Okay, like this. And because these two, the resistor B and C, are connected parallel, so I can combine them as an equivalent resistor. So I draw another diagram which is like this. Here they combine and become an equivalent resistor. And when looking in this diagram, you can see that this diagram actually the same as the diagram in part B, and that means ID will be larger than IA. Yeah, that's enough. So by combining these two results, we have the final result, which is ID is the largest and it is larger than IA, and IA is larger than IB, and IB is equal to IC, like this. Okay, so I will put ID to the very left, which is the largest, and then IA in the middle, and IB and IC on the right, and IB and IC overlap because they equal to each other. And that answer is also correct. Well, that's it. That's all my problem. Thank you for watching. Bye.